Welcome to Mr. Mickleborough's Maths World, the way it is. Sorry I can't be with you today, fellas, but I need to show you this video. We haven't got any time to waste, so we're going to have a proper lesson today, yep? Now, we're talking about exact trigonometric ratios, and when we do that, we start with two triangles. One is an isosceles triangle here, and it's isosceles because we've got two sides that are the same length. By convention, we use 1 and 1. Okay. Now, Pythagoras is telling us that the length of the hypotenuse must be the square root of 2. Why is that? Well, Pythagoras is saying c squared, in other words, the square on the hypotenuse, is equal to the sum of the square on the other two sides. So c squared must equal 1 squared plus 1 squared. And so c squared equals 2, therefore c must equal the square root of 2, yeah? Okay, so that's how that comes about. Lovely. Now, what that enables us to do is to find exact trigonometric ratios for the angle 45 degrees. So if you look at that triangle and look at the angle 45 degrees, and because it's a right angled triangle, you know that the sine ratio, or sine of 45, must be opposite over hypotenuse. Yes? Sine equals opposite over hypotenuse. So that means the sine of 45 degrees is exactly 1 over the square root of 2. Okay? And we can also tell from this diagram that the cosine of 45 degrees is the adjacent over hypotenuse, and that's also equal to 1 over the square root of 2. What about the tangent ratio? Well, what's tangent? That's opposite over adjacent. So the tan of 45 would be 1 over 1. So tan 45 equals 1 over 1, which of course just equals 1. Okay, so we've got three exact trigonometric ratios. Looking at our second triangle, now how that's formed is that we've started off in fact with an equilateral triangle, with sides arbitrarily set at 2 units. So it's 2 there, and 1 plus 1 is 2 there. So we've got an equilateral triangle. That means that angle is 60 degrees, so would that angle be, and that one as well. Now what we've done is we've bisected from this apex here down to the base, that triangle, and that means that angle is 30 degrees, and we've got a right angle here, so we've got a right angle triangle. Now once again, by Pythagoras' theorem, we can work out, because this is 1 unit from there to there, and that's 2 units from there to there, we can work out that shorter length, can't we? And it turns out to be the square root of 3. If that's 1 and that's 2, that'll be the square root of 3. That, of course, is because when we're finding a shorter side, see that's the hypotenuse there, isn't it? The hypotenuse is the longest side. So when we're finding a shorter side, you use this version of Pythagoras' theorem. C squared equals the hypotenuse squared, let's call it A squared, minus the other side squared. So in this case, c squared is going to be 2 squared minus the other shorter side's 1 unit, so it's minus 1 squared, and therefore c squared equals 3, therefore c equals the square root of 3. So that explains that there. Okay. So once again, we can find some exact trigonometric ratios for, in this case, 30 degrees and 60 degrees. So let's go ahead and do it. Okay, looking at 30 degrees first, we can see that for 30 degrees, if we go opposite over hypotenuse, we see that sine 30 equals 1 over 2, which is a half, of course. And similarly, if we look at cos 30, what do we get? Cos 30 equals adjacent. Well, the adjacent side is root 3 over the hypotenuse, which is 2. And tan 30 is going to equal the opposite side. Well, opposite 30 is 1. And the adjacent, so that's root 3. So tan 30 equals 1 over root 3. Okay, and you can work out similar ratios for 60 degrees, can't you? In fact, why don't you do that now? Find out sine 60 degrees. Okay, so I'll just tell you quickly, that's opposite over hypotenuse, so it's root 3 on 2. And you try cos 60 and tan 60. Okay, find out what those are. Okay fellas, I'd like someone to press pause at this stage and leave this displayed on the board. So that's what I'm asking you to do. Those triangles that I had shown you just now, they're also on page 216 of your textbook in the turquoisey coloured box, the lower right hand corner of that. So copy those out. They're very, very, very useful triangles and you need to learn those off by heart. The second thing I'd ask you to do is answer question 7 on page 217. Now you've got some ratios there, exact ratios for angles such as 0 and 90 degrees as well. You can just use your calculator for those ones, but in our next video on the unit circle you're going to see where the exact ratios for 0 and 90 degrees come from. Just note at this stage that tan 90 degrees is what we call undefined, and in the next video you'll see why that is the case. So undefined or infinity. Okay, thanks. So remember, put this on pause or keep this on pause until you're ready to watch the next video. Bye bye for now.